Hello, this is Awotwi-Bonney, and this is my project for the DCIT309 exam. So this project is a microcontroller-based prototype for a smart traffic and street light control system, and it's designed to address two main problems. That's traffic congestion caused by fixed cycle traffic lights and electricity being wasted by street lights staying on during the day. And this solution uses adaptive timing based on vehicle presence and an automated light sensor to solve these problems. So let's get into the project. All right, so I'll run the project, then I'll explain as we go. So when we run, yes, I'll explain the traffic light cycle. What happens is that it will start from the red state and be in the red state for 5 seconds, and then move to the green state for another 5 seconds, and then it moves to the yellow state for 2 seconds, and then it loops. So this traffic light cycle starts from red 5 seconds to green, another 5 seconds to yellow, 2 seconds, then it starts again. So this is the first lab in the project for the exam. All right, so the next part is the adaptive vehicle detection. So to handle congestion in a real life situation, we have this we have a vehicle detection system which is simulated by this button here. So when we press this button on the green state, it extends the green state by 5 seconds, and it only does it once. So you don't it doesn't extend it more when you press it more. And what happens is that if you press it on any other state, it does nothing. It only extends it when you press it on the when it's in the green state, and it extends it by 5 seconds once. So this is the vehicle detection system of the project. All right, so the next part is the automated street lights, which will be simulated by this LED street light LED here, and we'll use the photoresistor here to simulate daytime and nighttime. So if I were to simulate daytime, you can see that the street light goes off and there's no light. But when I simulate nighttime, which is when I reduce the illumination in the system, you can see that the street light comes on or it turns on, simulating the automated street light. And this does not is not dependent on the traffic light cycle, meaning that they are independent of each other. The street light does not affect the traffic light cycle, and the traffic light cycle does not affect the street light system. So both are in the system in the project. They are in the system, but they are independent of each other, which means that when one's paused, it doesn't affect the other one. So yes, this is the automated street light system. Thank you. All right. So the next part is the alert and emergency system. So to handle an emergency or in a situation where there's an emergency, we have the alert and emergency system, which is simulated by this button here. So when we press and hold the button, the buzzer sounds and all traffic lights move to the red state to sound an emergency. So let me demonstrate. So I just pressed, I'm holding it, and you can see from our serial monitor it says emergency mode active, meaning that all the states are the buzzer sound, and we also hear the buzzer sound, and all the traffic lights are in the red state. But when we release, it says emergency cleared, resuming normal operation, meaning that everything will resume normally starting from the red state. So yes, this is the alert and emergency system in the project. Thank you. All right, so let's look at the whole integration of the system. So look at how the system works when everything is working at the same time or under pressure or under stress. So I'll run it. So I'll simulate nighttime, which will turn on the street light. It's on. Then when there's heavy traffic, so I extend the beam by 5 seconds. But then there's an emergency, so immediately I press or I hold the emergency system or the system, which will sound the alert and then put all states to red. Then finally the emergency is over, so I release and everything resumes normal. And let's see if it resumes or works under pressure. And yes, as we can see, the project or the system works even under pressure. So this is a full integration of the project or the system. Thank you very much. All right, so let's look at the code. Now, major requirements for the system integration of the system was to avoid using delay functions because they would block the microcontroller from reading the sensors. So instead, we used MINS, which is non-blocking. It's a non-blocking approach. So every time a new state begins, the system records the start state time. And inside the main loop, it continuously calculates the elapsed time, the time that has passed, by subtracting the start state time from the current internal clock. That was, and then once the time has hit the target duration, then it will trigger the activate state, which will move on to the next state and then resets the time. So what that's one of the major codes for the integration of the system. Okay, so finally we have the servo gate, which opens or it's closed when the state is in red or yellow, and it moves 90 degrees to open when the state is green. Now someone will ask why I decided to make it close when it is yellow. It's to prevent in a situation where there are late arriving vehicles and they are rushing to enter the intersection during the yellow state. It's to prevent them from trying to enter when the state is red. So when it closes when it's yellow, no one can enter when it's red. So yeah, this is the server, the bonus part of the project, which is the server gate. So yeah, this is the full integration of the project. Thank you very much for listening. See you.